Hey all, in today's video, we are diving into Azure Machine Learning to build a predictive diabetes model. So today we will walk you through the entire process, from understanding the data, choosing the right machine learning algorithm, and training the model to predict diabetes outcomes, which means whether a person is diabetic or non-diabetic. And by the end, you will know how to apply Azure's powerful tools to create real-world solutions in healthcare data analysis. And if you're ready to take your AI/ML skills to the next level, we are offering a free masterclass that covers more in-depth topics like Azure ML, data pre-processing, and model deployment. So join professionals like Utkarsh, Shrija, and Devashish who transform their careers with hands-on skills just like these. So don't miss out, sign up today. Professionals who have mastered the techniques in this course have landed high-paying roles in top companies. So if you are ready to write your own success story, this is the opportunity you have been waiting for. The registration link is right there in the description and pinned comments. So now let's move on to the video.
So let me take you through the content that we are going to cover for today. We'll go into a project which is about building a predictive diabetics model with Azure Machine Learning. And this is for people who want to enter into healthcare domain or any other domain, to be very precise, wherein they want to learn how to use Azure Machine Learning for predictive diabetics model. Okay, building. All right. Now, for this, the first thing that we need to check is, I'll show you something which is called as the data. So this is the data that we have in place. Okay, wherein we have some values, if you can see. Before we go ahead and understand what are the different types of machine learning that we can go ahead and apply, first we'll look into data set. So suppose this is the data set of people who were diabetic or non-diabetic from the previous, you can say, information that we have in place. So here you can see we have got some information. And before we go ahead and look into this information and try to understand this information, let's just have a quick overview of this. So what we are able to make sense out of the first value is there is something called as pregnancy. Second thing that we can see is we have information about people who had some glucose level in their body. The next thing that we can see is blood pressure information about the people. Next, what we can see is the skin thickness. Okay. And finally, we have insulin level and the body to mass index information. There is also something called as diabetes pedigree. Basically, we mean to say that was there someone in your family who was prone to diabetic or not? That is what we have. And finally, we can see we have got another thing which is called as outcome. Okay. And what are we being told to do is we are trying to build a machine learning model on top of it. All right. Now, let me just take you through something important. So suppose you are working in an organization and the boss of that organization came to you and gave you this sheet. Okay. So again, I'll repeat, you're working in an organization, someone came from the organization and you're working as a data scientist and they went ahead and gave you this sheet. And they told that what do we need to do? They have just told that we want to build a machine learning model. So someone came, gave us the sheet, told us build a machine learning model. The moment someone says that we need to build a machine learning model, the first thing that will come to our mind is what type of machine learning model. Okay. Now for this, when the moment you say what type of machine learning model, there can be two types of machine learning model. There is something called a supervised machine learning model. And then we also have something called as, we have supervised machine learning model. And then we have something called as unsupervised machine learning model. Okay, so there are two types of machine learning model that we have in place, supervised and unsupervised. Okay, you have this too. Now, the moment someone says build a machine learning model, you will ask whether it is supervised or unsupervised. Suppose the person says you that it is supervised. Suppose the person confirms that it is supervised. Okay, so the moment someone confirms this as a yes, okay, other thing will automatically turn as a no. Okay, that means only one type of machine learning can exist, either supervised or unsupervised. Okay, or if someone says it is unsupervised, automatically you will understand that It is not a supervised one. This is what will be able to make sense. Now, once we understand supervised and unsupervised, in the supervised, there are two categories. There are two categories. The first thing is there are two categories. The first thing that we need to understand with regard to this is look at the outcome variable. Look at the outcome variable that we want to predict. That we want to predict via our ML model. Okay, so suppose the moment someone shows, I told you look at the output variable. Now, when you look at the output variable, someone will come ahead and explain you which is this output variable. Always remember, you need to define the find the output variable. Okay, so someone will come and tell you what is the output variable. So the output variable can be two types. It can be a continuous one or it can be a class based. Suppose if someone says that predict the marks of students. Okay. If someone says predict the marks of a student, I would like to know from you, will it be a number or will it be a grade? I'm just talking about general sense. Will it be a number or will it be a grade? All right. So if it will be a number, this type of machine learning algorithms are known as regression. Always remember when we are talking about regression, we are talking about output variable. Okay. Talking about output variable. So if it is a number that you're going to predict for the future, it will be regression. If you're trying to predict grade or class, okay, then it will be called as classification. Okay. Now what I'm going to tell you, I am going to tell you what do I want you to predict. I want to predict for future whether the person will be diabetic or non-diabetic. So across all the features that you can see, which feature do you think will help me predict the outcome diabetic or non-diabetic? Which feature? Outcome. All right. So now this feature is going to help me predict whether it is diabetic or not. Now 1 and 0 here actually does not signify number. They signify whether the person will be diabetic or the person will be non-diabetic. Now how do you understand what is 1 and what is 0? Every class needs to have a label at the back end. So you should already have the label. In place. You cannot assume anything one to be positive or negative. So already have the label in place. Okay, or you can say metadata of label is important. So what is important? Metadata of label is important. Now if I ask you a reverse engineering, what can you see? Number or class? What do you see? Number or class in the outcome? If I'm going to build a model which is going to do prediction of person being diabetic or not, what it will be? Will it be a number or class? All right. So if it will be class, it will be class, right? Now, if it will be classed, will it be classification or regression? Which algorithm? If it is a class, will it be classification or regression? Classification. Wonderful. Now, next point that comes is, then what will be regression? If classification is class, then what will be regression? If classification is class based, then what will be regression? All right. Regression will be when we want to calculate the continuous number. Like what will be the age of a person who is going to be prone to diabetic. You're getting the point. What will be the blood pressure? All these are numbers. All right. All these are numbers. Okay. Now let me just come back to that same question again. So I have got a sheet. I am able to identify whether it is a class or a number. Who decides which algorithm will be used? The class decides. Okay. If that is the case, my point is pretty simple. Does selection of algorithm depends upon input? Does selection of algorithm depends upon input, what you can see here, or does it depend upon output? Selection of algorithm. On which parameter does it depend? On the input parameter or the output parameter? Selection of algorithm. Whether it will be a regression or a classification depends upon what? Depends upon output. Now, if output is outcome, then whatever is left is input. Now, I want you to help me out, everyone. Out of all the input that you can see, starting from glucose up to age, tell me which are class based. Tell me if there is any variable which is class based. From input, I am saying, from glucose to age. Do we have any input class based? Wonderful. Do we have input as class, no input as class based, everyone? I think that's absolutely right. Okay. And do we have an input as number based? Which are the inputs that are number based? Which are the inputs that are number based? All right. All right. Now let me add one more feature for your understanding. I am adding a feature which is family history. Either 0 or 1. Now let me know this is a number or a class. All right. So can we conclude that input feature, whatever might be the algorithm that we will select, can we conclude that input feature can be a number or a class or both? Everyone agrees? Can we conclude that input feature can be a number or a class or both? Yes or no? Now, if that is the case, output variable will depend upon what? The input variable. And the output variable will be a class or a number. Tell me. For regression, what it will be? For regression, it is number. And for class, it will be which algorithm? Wonderful. That's great. Thank you. Now, my point is pretty simple again. We'll go ahead. So we are able to understand that we want to build a predictive model which should be able to see the outcome in the previous, what you can say, model training. The outcome is coming from the data set. That is also pretty clear. Okay. So basically, what do we mean by this? We basically mean that machine learning algorithms are data driven. The better the data, the better the response. The least the data and ambiguous the data, the response will not be fair. Continuous basically means something that is not a class. I'll give you an example. Anthony will be able to purchase the house in 2025. Yes or no? What is this? Anthony will be able to purchase the house in 2025. Yes or no? Is this a number or a class? Class. Now let me change the question. What will be the price of the room in 2025 when Anthony will go to buy? Will it be a number or will it be a class? Wonderful. Wonderful. So what are we able to understand, people? We are able to understand that if the number is continuous, it will be regression. If the number, so basically what will be the salary, okay, of an individual if he leaves the job? This will be a continuous number. So in this case, what will be applied? Regression or classification? That's great. You have yourself answered the question. Congratulations for this. All right. Now, let me take it ahead from here. Okay, now what are we going to do basically? We are going to do Azure Machine Learning we will use to build our model, okay, a regression model, which is actually going to tell whether the person is we will build a classification model using classification algorithm to predict whether the person will be diabetic or non-diabetic. All right. All right. Now my point comes is, have you all explored Azure Machine Learning till now, or are you still in the stage of exploration of Azure Machine Learning? Let me give you a brief about Azure Machine Learning. So what is Azure Machine Learning? Azure Machine Learning. Okay, this is a resource in cloud. So there is something called as Azure Cloud. So we have something called as Azure Machine Learning. Azure Machine Learning is part of the cloud, Azure Cloud. Azure Cloud has many services. It has many services. Okay. And when you want to use this many services, you need to deploy an instance of it in the cloud. So there are many services. You need to deploy an instance of service in your subscription. Okay, you need to deploy service instance of a service in your subscription. This instance of service is called as resources. Is called as resource. Now, whenever you want to create a single resource or a multiple resource, maybe I want to create one resource. Remember what I'm saying? Maybe I want to create one resource like Azure Machine Learning, or maybe I want to create multiple resources. So maybe I want to create more than one resource. Okay. Now, whenever you want to create any resource in Azure Cloud, you need to create resources, either one or many. Okay. To create a resource, either one or many, we need to create something called as a resource pool. Okay, so this is a container which is going to contain your resources for your project. I hope that's clear for all. I hope that's clear. Now I'll ask you all folks to give me an answer. What are we trying to do here? Classification or regression? Classification. How do you know it is classification? How do you know it's classification? Looking at the outcome. All right. So looking at the outcome, this outcome is what we call as target variable. Okay. This is what we call as target variable. Okay. This we call as target variable. We also call it as dependent variable. So we have a target variable which we call as dependent variable. Okay. Now, whatever is left over apart from target variable is called as input variable. Okay. Or I can say this to be called as a feature variable, or we call it as independent variable. Yeah. So what I'm saying is the target variable is also called as dependent variable. It's also called as output variable. Okay. The feature, okay, apart from target, everything is feature, is also called as independent variable. It's also called as input variable. Now, what is our aim? Our aim, suppose if output variable is y and input variable are x1, x2. Now, my point is, will we have more than one output variable or only one output variable? Will we have more than one output variable or one output variable for one data set? 0 or 1 is just a class of that output variable. But how many output variable? 1 or more than 1? 1. Will we have more than one input variable? Is it possible? We can have one also, but in reality, input variable, can we have more than one? All right. That means if I put it in a simple way, you can say that if I say output variable is represented by y and input variable is represented by x1, x2, x3, x4, and so on. So you can easily say that y, or I can say dependent variable is a function of independent variable. Okay, simple. Dependent variable is a function of independent variable. That means dependent variable is a function of independent variable. Okay, it is a function of independent variable, which can range from 1 to as many as we want. Consider this to be common. All right. That also sums up one more important thing. A very important thing it sums up, that dependent variable is a function of independent variable. That means what we try to do in automated machine learning, okay, or what we try to do in machine learning is we try to find, I'll put it in a very simple way, we try to find pattern between output and input. Output and inputs. Okay. So once we find the pattern between output and input, that is being captured using an algorithm. So we use an algorithm. Remember this, what I'm saying? We use an algorithm to capture relation between output and input. That algorithm, when it captures the relation, builds something called as a machine learning model. What does it build? It builds a machine learning model. So this machine learning model has encapsulated the relation between input and output. And how has it encapsulated? Using an algorithm. Okay, done. Now, once this model is built, once this model is built, now, once this model is built, we build the model. Okay, once this model is built, this is built. Okay, now we want to check how is the model performing. I'll give you an example. I have a child who is 6 years old. Okay, now if my child is 6 years old, first I wanted to train him. I wanted to train my 6 year old child to classify the app of to classify whether the fruit is an apple or not an apple. Okay, I want my kid to understand and classify whether the fruit is an apple or not an apple. So if I give him the fruit on the day one without teaching him anything, will he be able to do? Absolutely no. And that's where the logic comes. Now, that's great to hear. Now, what I went, I know I directly gave the fruit. Okay. And child was not able to do anything, no answer. Then I understood that my child does not know. Okay. So, what I did, since my child does not know, okay, I went ahead, okay, and showed him apples. Okay. So, on first time, I showed him red apple. Then I showed him orange apple, orange reddish apple. Then I showed him what you can say, green apple, greenish apple. Okay, I showed him 3 apples. And I showed this apple to my child for 15 days. Just showed him the apple. Okay. After showing him the apple, I showed him an image. Okay, I showed him the image of a fruit. And my child told that this is an apple. But actually, it was not an apple, it was pear. Now tell me, is my child good enough to identify if he's saying apple is pear? No. Now, why has my child told that it is a pear, according to you? Based on which feature? What do you think? Which feature? Color and maybe the shape also. A little bit of shape, color and shape. Absolutely correct, right? Color and shape. So I understood that my child is not good enough to understand whether it is an apple or a pear. I made him eat the apple next time. Okay. I also showed him that in apple, the seed is at the center. Okay. And in pear, the seed is spread over. Just giving an example. Suppose it is guava. Consider this way. And then when I showed my child an apple, he also ate a bite of it, understood the taste, saw the seed, and then told me the correct answer. You're getting the point? Are you able to get the point? So this is just the training. Understand, this is still the training. I've just trained the model. I have just trained the model. Now comes my another thing. Since you people are from US, you know that American apples are little, yeah. So you know that American apples are little dark reddish in color. I hope you all know. All right. Now, did I show him American apple, the dark reddish apple? All right. Now, if I show him dark reddish apple, understand what I'm saying? This data he did not see. This color he did not see. The It is also a little more solid, American apple. It is also a little crunchy when you eat, right? As compared to other apple. So I did not show him this apple. And I showed this apple after training the kid. Now, this, if he is able to identify, is it a good trained model or not? If he is able to identify. This is what we call testing. You're getting the point? So, what did I do? I showed him 3 types of apple and trained the model. After then, I showed one more apple which is similar, but the model has not seen. And then I tested the model. You're getting? And if the testing is correct, then I will say that, hey, my model is pretty well trained with a very good accuracy. Suppose I gave him 7 apples, all were different types. Okay. And suppose some were based on the training data set and some were based on new sample. Okay. And out of 7, if my kid identifies, I'll put it this way, out of 7 apple that I showed him, if my kids identify 5 apple correct, so what is the probability of accuracy? The probability of accuracy will be 0.714 something. Is it correct? 71.5? 5 out of 7 I told. Is it correct? Everyone agrees? That's it. Absolutely. So this is called as first train the model, then test the model. When you test, check the performance of the model. Okay, once you check the performance of the model, then you go ahead and deploy the model in production. All right. This is end-to-end machine learning lifecycle. The deployment basically means, see, first you train the model. How do you train the model? Show the model input. That means show the model features and also tell him the labels. Show him the features and the target. Okay, that means show him X and Y, both. Okay. Once the model is trained, then you would like to test the model. Test basically means you will now use the model. Okay, use the model. So this is the model. You will show the model. You will ask the model now. What are you going to do? You will ask the model, give all X, give X, and ask the model to predict Y. What I am saying? Give X and ask the model, hey, predict Y. Okay. So suppose you told the model to predict Y. Okay. And suppose this is my data set. Assume what I'm saying. So this is my data set. What did I say? I showed the X. I showed X. There are different X, right? X1, X2, X3, X4, X5. So I gave all the X to the model and asked the model to predict Y. What did I say? Predict Y. Okay. Suppose first I showed him green apple. The person told green apple. Then I showed him red apple. Okay. And the person told it's cherry. Assume it, the person called it as a cherry. The third time I showed the person, you can say maybe I showed the person a little orange apple and the person told it's an apple. Did not say the orange. Okay. Next time I showed a red American apple and the person told that it's a red and American apple. Now, if I ask you, is the first answer now? What is the actual value? We know the actual value. Actual value was it's a green. Actual we know, right? And then the next one was red. Next one was orange. Next one was red American. Now, if I ask you, is the first answer correct? You will say yes. Second answer, no. Third answer, yes. Fourth answer, again. Sorry, I just messed it up. Fourth answer is again yes, right? So first answer, yes, correct. Second answer, correct. Third answer, incorrect. Fourth answer, correct. Now, if I ask you, what is the accuracy? You will say 3 by 4, which is how much? 0.75. Okay. This is called as testing of the model. Now, if you are happy with the testing result, you will put this into the production. And for that, you will deploy the model. You will deploy the model and say that, hey, I have got a model which can give you 75% accurate result overall. You got the point now? All right. Now, before we go ahead and see other things, let me delete all this because I need the data to be clean. So what I'm going to do, what are we going to do? We are going to use a service called as Azure Machine Learning. In this, there are different ways to train a model. Today, we are going to do train, test, and predict. So we will train the model, then we will test the model, and then we will deploy the model to get the prediction. Okay. So when I say train, test, deploy, let me just put it here. So when we say train, we will show both X and Y. Okay. X and Y. When we say test, we will show X, ask the model to do Y predict, compare it with Y actual. Okay. Actual Y. And then find evaluation, like find accuracy, or we can call it as metrics performance. Okay. Next comes deployment. Here we show X, we ask the user to put X, and we put it in production to directly find Y. There is no testing here. This is deployment. Predict. Is it okay? And here find the performance matrix. And if you are happy, then you deploy. Now for this, Azure Machine Learning has a tool called as automated machine learning. It is a UI based tool. You can even use SDK. It is a UI based tool, automated machine learning. Sorry, I don't know what is the issue today. Automated machine learning. Now, what is this tool? It is a UI based tool to train, test, and deploy a model. All right, train, test, and deploy a machine learning model. All okay? So in Azure Machine Learning, we are going to do this. All good? Shall we proceed? All right. Now for this, the first thing that we need to do is you have a lab instruction which you can always follow. I'll go to home. I will create something called as Azure Machine Learning. Azure Machine Learning on the Azure portal. The moment I click on Azure Machine Learning, I need to click on Create and I need to create a new workspace. Here I'll create a workspace by the name Machine Learning Resource Group. This is the resource group. I told a container within which I need to create a Azure Machine Learning resource. The Azure Machine Learning resource is known by the name workspace. So when you want to create an Azure Machine Learning resource, you need to, the name for resource is nothing but workspace here. So let me call it as Azure Machine Learning resource. Okay, the moment you create, there is an important thing that you need to see. So the point is, if you remember, I told you something that you need to create Azure Machine Learning. Okay, those who are new may be able to make sense. So you need to create Azure Machine Learning. Azure Machine Learning has something called as automated machine learning. Now to create Azure Machine Learning on the cloud, this is the resource. You need to create this resource. And this resource, whatever you need to create, you call by the name. This is the same which you call as a workspace. Okay. Now what basically happens when you create an Azure Machine Learning resource, this is called as the main resource. Okay. And there are some dependent resources that automatically gets created. What are those dependent resources? Those dependent resources is a storage account to store your data, key vault to store your secret, application insight to check the application when deployed, the insight of the application, and container registry to create a Docker. Just to keep it simple, these are some dependent resources. Okay. And this will auto create. You can't skip. You can skip container registry right now, but it will get created at the time of deployment. At the time of deployment, container registry gets created. Now I'll hit on review plus create to create an Azure Machine Learning. So within this resource group, I will see within this resource group, I will see a workspace. This is my main resource. And I will also see 3 independent resources. Container registry gets created at the time of deployment. Okay, this is also a dependent resource, but this is the main resource. All right. So now I'll get a resource group within which I'll have 4 resources. If I would have enabled container registry, I would have got 5. So by default, 1 main resource and 4 resource again gets created. Now, if you see here, I am creating a resource. All good? Trying to keep the thing simple, and that should be helpful for all. Now here you can see resource is getting created. Now there is one more resource getting created. I'll tell you, this is log analytics workspace. Actually, application insight is dependent on log analytics workspace. Application insight is dependent on log analytics workspace. So what basically happens? Azure Machine Learning gets created, which creates a storage account, a key vault, container registry at the time of deployment, and application insight is created. But I told you, application insight is created, but application insight itself is dependent upon log analytics workspace. So you will see 1, 2, 3, 4, 5, and at the end, at the time of deployment, you will see container registry, which is 6th. So now this is done. Let me click on the resource. So I'm in this resource group. Let me go to home. Let me go to resource group, and let me click on ML resource group. And here you can see I have got 1, 2, 3, 4, 5. And here you can clearly see that I have got log analytics workspace and application insight. I told you both are dependent. Then key vault storage account, no container registry. Now I'll click on this resource. This workspace resource has got something called as Studio. This is the place where you develop your model. So you can click on this link, or you can click on this Launch Studio. So I can click anywhere. The moment you click on this, it will actually launch the Studio. Studio is a UI for end-to-end machine learning project management. Within this UI, you will use automated machine learning to build a ML model, a test ML model, and deploy, okay, using a UI again. Okay, UI form. So there is one UI which is called as Azure Machine Learning Studio, within which you have another UI which is automated machine learning. Okay, so if I go here, you can see there are different authors. I am interested into this author. So this is my machine learning studio. I came from workspace. Again, I'll show you. I was in the resource group. Under this, I went to my resource, which is main resource, Azure Machine Learning, under which I launch my studio from a URL or from this button, which took me here. And now I will go to automated machine learning, and I'll cancel this. This is where I can create an automated machine learning job. Job basically means an experiment. Job basically means an experiment. Now, if you remember your school time, you used to take multiple observations, right? Multiple observations. Okay. So job is nothing but experiment. Job is nothing but experiment. And job run is called as experiment run. So a single experiment can have multiple observation, if you remember your school experiments. So a single experiment can have more than one run. So I can have run 1, run 2 maybe, and run 3. And so on. You're getting the point? I can also have a one run, but if I want, I can have more than one run of the same experiment. Is it okay? Everyone is clear with what I'm saying? Yes, there is a cost associated to this resource. You can check with the documentation thing, but it's very minimum. Everyone clear with what I'm saying? So where are we? We are into automated machine learning. Okay, simple. Now, I'll tell you, once you will create a job, you will run it for the first time. So a single experiment, which is a job, can have one run 1. Then you can have another run on top of it, which you can call it as run 2. So anything you want to see, you will see it under the job section. Once you will submit the experiment, you will see it under the job section. So once you submit the experiment, you will see it here. Okay. Now, if I click on this, I told you here you can see all experiments and there can be multiple runs. They call runs as jobs. So all experiments, you will see it here. Within the experiment, once you click on that experiment, you will see all the jobs of that experiment here itself. All right. So we will create a automated machine learning resource. I hope that's clear for all. The point is we need to build a machine learning model, right? And to build a machine learning model, we did discuss that we are going to use some algorithms, right? I'll take you a high level overview. Let me just take it through the same process again. So first thing is we need a data set. Okay. In this lab right now, since our aim is to build a machine learning model, we'll not be doing pre-processing. Okay. So the data, you can consider it to be cleaned one. Okay. Generally what happens for a machine learning experiment, you would like to get the data maybe from different sources. And then you would like to clean the data. Once the cleaning of the data and pre-processing, you can call the stage as. Okay. So once the cleaning and pre-processing has happened, then you get a data set which is ready to be used for your machine learning purpose. Okay. In our case, we'll directly be using a data which is a cleaned one. The name of the data is a diabetes data. So we have something called as diabetes.csv file. What is our aim? We want to build a machine learning model which is going to predict for future data that whether the person is diabetic or not. Okay, this is what we want to predict. Fine. What do we have in this data set? I told you we have some inputs, which we call it as features, or we also call them as independent variable. The second thing that we have in the same data set, we will have our output, which we call it as targets, or we call it as dependent variable. Another thing that we need to understand is, I told you we will be using automated machine learning. So since we'll be using automated machine learning, we will be creating an experiment job, which will have multiple runs as per our requirement. Now, one important thing that we need to understand before we go ahead with automated machine learning is automated machine learning, okay, runs, I'll just put it this way. So suppose there is one algorithm created by Jalal. Okay, suppose one algorithm created by Jalal. When I'm talking about algorithm, we basically call it as mathematical relation, okay, or mathematical intuition, or in a simple way, you can call that at the back end we have some mathematical formula, okay, which can solve the problem. Okay, so suppose one of the algorithm has been designed by Jalal, another algorithm has been designed by Atul, there is one more algorithm that has been designed by Pranjal. So what is basically going to happen if we use this algorithm to train our data? So we have our data and we want to pass this data, okay, to this algorithm. When we pass this data to this algorithm, we will be able to build a machine learning model. So suppose we build a machine learning model by the name ML Jalal. Again, we took the data. This time we use this algorithm. And once we use this algorithm, we again got a model, and you can call this model by the name ML Atul maybe. Okay. Again, you used another same data. You passed it through this algorithm. And again, you got a model created out of it, which is going to be suppose called as ML Pranjal. The point is, how are this model different? This all models have tried to, all this model had tried to build a relation. Okay. So all this model have tried to build a relation between Y and X. Okay. All this model. The only thing is, since the algorithm is different, The relation will be different, but the formula will be the same. The relation can go a little bit here and there, but the formula will be the same. So what basically happens in automated machine learning is, if I try to give you a definition of automated machine learning, multiple algorithms, okay, leads to multiple models. So you select multiple algorithms to build multiple models. That is one thing. Now, if I build multiple models, okay, I will be able to train model 1. I'll get machine learning model 1, I told. Maybe I'll get machine learning model 2, and maybe I'll get machine learning model 3. Now, once the model has been trained, here you can see that the model has been trained. Now, after training, what do? We test the model, right? So suppose now I want to test the model. So suppose I want to predict whether the person is diabetic or not. And in the test data set, suppose I have got 10 samples. I've got 10 samples. Now, if I have got 10 samples, maybe for the when I use the model number 1 to test my 10 samples, I got 8 results correct out of 10. For the second one, maybe I got 7 results correct out of 10. For the third one, maybe I got 10 results, 9 results correct out of 10. Now, if I'm asking you, which is the most accurate model, what are you going to say? Which is the most accurate model? Wonderful. How did you find it that the third one is the most accurate? Performance metrics. And what is the performance metrics right now? Accuracy, right? Absolutely. That means, I'll again give you a definition. What is automated machine learning? It is a way to train multiple models using multiple algorithms and find the best model based on performance. Okay. So you train multiple models. How do you train multiple models? Using multiple algorithms, and you find the best model based on the performance. Now let me take it ahead from here. Now I want to create a job. Let me click on this create a job. So this is the form that I need to fill. So I've selected the training method first of all, that I want to do automated machine learning. The second thing that it is asking me is the name of the job. So the name of the job is the run name. So I'll call it as run 001. Okay. It is asking me the name of the experiment. So right now there is no existing experiment. So it will by default create a new experiment. So let me just call it as diabetes ML experiment. Now what do we mean by this? In this experiment, I am going to have this run. Okay, but in the same experiment, and next time it will be existing. So I can add more runs also. Now let me just say description, build a machine learning model, okay, to predict whether the person is diabetic or non-diabetic. This is fine. Now let me click on next. So I filled the first thing. Next it is asking me the task. So which task shall I select? I am going to select regression or classification. Will it be a regression or classification? Classification. The next thing that it is asking me is, where is your data set? So I do not have a data set. Let me create a data set. I'll give a name to my data set. I'll just call it as maybe diabetes data set. I can just say, give it a description, diabetes data set. I'm okay with table because it is a tabular data. And now I can select the data from maybe a local file. I'll click on next. I can select a storage. If you remember, there is a storage account. So if I come here, if you remember, we were getting a storage account, right? So here you can see I'll have a storage account. So in this storage account, I want to keep my data. So I'll use this blob. I'll click on next. And here you can see this is the path where the data will be uploaded. Now for that, let me just show you this path and I can show it to you from here. So here you can see it is actually going to go through a workspace blob store and it is going to create something as a folder. So what I'm going to do, rather than creating a folder, let me use a very simple way. I want to upload a data. So let me just select tabular data. I'll click on next. I'll select maybe local files. Click on next. I'll select blob store and see the storage account AML resource 1834. This is the same name that you can see here. Now in this, there is something called as container. This is where I'll have the blob. Okay, so what I'm going to do, I'll just click on next. Now it is going to ask me to upload a file. So I can upload a file or a folder. Right now I just have one sheet. So let me just upload the file. This is the file. I'm just uploading the file. The moment I upload the file, this same file, you will be able to see it somewhere here. So let me just validate. Let me copy this and let me just showcase this too. So if I show you, I have a workspace blob store and this is where the data will go. So if I go into this, can you see a UI folder getting created? This is the same UI folder that we are talking about. So I'll go to the UI folder, within which you can see as per the UTC, a folder has been created. And this is where I can see my diabetes.csv data. Okay, so this is my diabetes.csv. I'll select the file format, which is delimited. It is a comma separated value. All files have same header. This is also okay. You can say only first file has header because this is just a single file and it has a header. Okay, now once this is done, I can come up here. This is the file. I can see the preview. I can go to next. Here I can select if I want to change the schema of the data. So I'm okay with the schema. It is giving me some schema. If you want to change the schema, maybe you want to say outcome is a boolean, you can select that. Okay, whatever you want to select, you can select. Family history, if you see, is a value, so you can select family history. I have added family history. Actually it is blank. I had to delete this, right? I just added it for our namesake. So let me just remove this. Okay, let me go back then and let me upload another file. I'll say upload the file and overwrite because I do not have anything as family history right now. All right. Now, if I want to change anything, maybe I want to change this data type. It is considering it to be an integer. Maybe I want to call it as a boolean. Absolutely fine. So if you want to change anything, you can change it. You can change it. That's a good thing. You should change that right now. Let me just keep. No, it's a permanent storage. It is stored here. It is stored here. You can see it is stored here. Okay. It's a permanent storage. Is family history still there? Let me just check. Okay. If that is the case, let me cancel this. Let me come up here. It should have overwritten. Let me just delete this. Now let me click on the data set. Now I think it's perfect. Let me hit on create. Now what I'm doing right now, the data is already stored here. It is saying delete failed. How come? There will be another folder created. Yeah, this is fine. Now I'll select this. I have selected the data and the task type. Let me click on next. Now I need to select a target column. Now tell me, what is the target? What do we want to predict? Outcome. Let me just select outcome. If you want to enable deep learning, you can enable. I'll show you feature configuration setting. This is very important, configuration. Here you can see what is your primary metric. You remember I told accuracy? There are different types of metrics. So suppose I select accuracy. Then do you want an explanation for the best model? Okay. And here you can say all supported model. If I uncheck this, I can select. There are so many algorithms. I told you Jalal, Pranjal and Atul. Maybe I just want to use logistic regression. Or maybe I want to use decision tree. So I can select this too. Okay. And now I can click on save. So here I have selected what algorithms do I want and which metrics do I want and do I need an explanation for which is the best model. Next comes featureization. When you build a model, okay, you do not only get accuracy. I'll put it this way. Suppose I got first model as model 1. I have got another model as model 2. And I've got another model as model 3. All right. Now what I have told, suppose I'll put it this way. I have selected primary metric as accuracy. Suppose this is 0.9, this is 0.8, and this is 0.95. Now tell me which is the best model? 3, 1, 2. So when I get the result, this will be my ranking. Because, listen, let me complete. Okay, this will be my ranking because my primary metric is accuracy. This will be the ranking. So now based on the ranking, you can deploy this model. But that doesn't mean it does not calculate other. It also calculates other metrics. But it ranks it based on your primary metric. You're getting? Maybe the model number 2 has an accuracy of 0.8. Okay, has an accuracy of 0.8. But there is one metric that you really like, maybe precision. Okay, and suppose it has a precision of 0.9896. So you can even deploy this model. It's absolutely fine. You're getting the point? Is that okay? So the ranking is based on which primary metric have you selected. Is it okay? So if I click here, the primary metric will decide the ranking. That's okay. Is it okay? Then there is something called as featureization. What is featureization? Suppose if there is any missing value that needs to be calculated, because machine learning model cannot take blank spaces. They need numbers. Okay. So missing value can be imputed. Like assume there is one of the value which is pregnancy. Okay, and there are missing values for pregnancy. So since it is a number, can you see it is a number? It will replace it with mean. Sorry, it will replace it with median, or it will replace it with mean. Anything it can replace. The best possible. Generally, it does by mean, but you can change. Here you can see option. Can you see mean, median, fill with constant? If there is any missing value in this pregnancy, I want you to see feature type. What is the feature type? You can specify automatically detect what is the data type. Then impute it via mean, median, mode. Mode means most frequent. All right. Right now, this is a very simple thing which works for finding mean, median, mode. Now, there is a very important thing which is limit. If I click on limit, what do we mean by limit? I'll tell you. See, basically what happens, there are maximum trials. See what happens, a algorithm can run for 168, not algorithm, a experiment can run for 168 hours, which is actually 7 days. Okay, 7 into 24, if you calculate 7 days into 24 hours, you will find 168 hours. Now, you may not want the experiment to run for so long. Okay, so you can specify if we get 10 trials, 20 trials, how many? If you remember, there are 3 experiments, right? So maybe I want to get the top 2 trials. There can be hundreds of experiments.
How many maximum concurrent trial do you want to run? So there is a VM which is going to build a machine learning model. So I'll say maybe maximum 2 concurrent trials together. How many nodes should be utilized? Suppose I have got a compute which has 10 nodes. So I can specify how many nodes do I want to utilize at one time. What should be the metric threshold? So here, if I say, if the accuracy reaches 0.95, stop the experiment. This is all limits. I want to stop the experiment. Why do we need to stop the experiment? Maybe I do not have that much time. If I get an accuracy of 0.95 with 2 trials running concurrently on 2 nodes at a time, I am okay. Suppose I say maximum timeout. So I can say each experiment should not run more than 15 minutes. Each experiment I am saying. Experiment timeout means each run. I am talking about each run. Okay. Sorry, this is total experiment time. Really sorry. So I can specify my experiment should run. I told you 168 hours it can run. So maybe I can say in minutes, I'm okay to run it for 300 minutes. Just giving an example. After that, stop my experiment. Every iteration, I do not want to run more than 15 minutes. If you're not getting the result in 15 minutes, stop it. You're getting the point? So there is also something called as early termination. If I click on this, early termination also you can enable. Now we will cover what is early termination when we will cover something related to DP100. Okay, is it fine? I'll explain you what is early termination. All right. Those who are part of already existing session, they are aware. Now, if you remember, validation is what we call testing. So do you have testing data? You can say automatically select, and there are different types. So this is called as train test split. So what do we do? We have a data set. I'll show you. This is my data set. So what do I want to do? If I see this data set, if I select all, how many values do I have? I have around 768 values because first is the header. 768 values. So what do I want to do? I want to take a cup of it, okay, and I want to use it for testing purpose. You getting? So general convention is 70-30 or 80-20. You can even put 60-40. What do we mean by this? Use 70% of the data at the time of training. That means show the input and output both. Show input and output both to the model. This is all my input and this is output. Show both. Train the model for 70% value. Then comes 30% of the value of my data set. Only show input. What we will say? Only show input. Where is the thing? Yeah. Sorry, where's my cursor? Only show input. Ask the model to predict the output and compare it against this. This you can see this. Compare this value if you can see this column. So compare it against actual. You're getting? Compare both against each other. So for 30%, I want to compare. This is called as train test split, or we call it as train validation. Validation is another word for testing split. Okay. Making sense what I'm saying? So if I'll put it this way. So if the values generally will not have so less value, if the values are up to 100, put a 70-30 split. This is the convention. If the value is greater than 100, generally you will have greater than 100. You can go for 80-20 split or 60-40 split because 20% of 1000 is also huge to test. Okay. I hope that makes sense. Okay, that impute auto means it will automatically consider. No, it does not select random value. It selects on the something called as, what do we call, stratifies. It does the stratification. So right now, let me just put 30%. Okay, now this is done. Okay, if you have a test data, you can use the test data also. I do not have the test data. So I'm using the train data to do the split. I click on next. Then it is saying compute. I'll go with the serverless compute to build. And how many instances do you want? Maybe I'm okay with 2 instances. Okay, so you can select any. I'm okay with this 1 instance and let me click on next. And then I'll click on. So this is all my experiment. I'll click on submit job. Now remember the name of my thing. Sorry, it is saying. Okay. Total iterations, system expects at least 3 iterations. All right. So I did not give more than this. It expects at least. Sorry, there is some issue. It's not showing my. I need at least 3 iterations. So let me just play with this. It requires at least 3 iterations. This is 3. Maximum concurrent trial, I'm okay with 2. But I do not have more than 1 compute. So let me just put 1. Because there is a limit with respect to my thing, my subscription. So I'm okay with this. Okay, now everything looks to be fine. And now let me submit the job. So what I'm doing right now, I'll just come here. So I'll go to the job now. This is my experiment. In this experiment, I will have all my runs. So this is my run. If I click on this, it will start, it will complete. Within some time, you will see the things in action. So right now I'll click on this and you can see the experiment running. The experiment will start in some time. Can you see it is setting up the run? From where is the data set coming? This is my diabetes data set, which is coming from here. Okay. And here you can see all the tasks that I have set. Task is classification, featureization has been enabled, and I can see that configuration here itself. Deep learning disabled. What models did I allow? Only 2, logistic and decision tree. Explain the best model I told, accuracy I told, and this is what I'm getting. Task is classification. Did I specify any exit criteria? Yes, I did specify some exit criteria. Training time for the total experiment is 5. Threshold is this. I've told everything. Concurrency, you can see maximum concurrent iteration 1. Some additional setting, if there is any, you can check that out. Okay. So let it run this time. You will also show us without using GUI to create. Right now, no money because that we have it in the DP100 course. This is about automated machine learning directly using UI. Okay, we will be doing that in another course, which is DP100. I'll take you to something called as data. All right. I'll click on this create. Okay. Rather than showing you this, I'll show you something different. I'll go to data store. Okay. I'll click on, I want to create a new data store. Data store points towards storage. Okay. Rather than connecting to a blob storage, maybe your data is there in SQL database. Can you see? Okay. So here you can see, you can get the data from PostgreSQL, Azure SQL, MySQL, Data Lake, which is a big data system, or you can get it from file or blob. Now, the point is, I'll just put it this way. Right now, we do get a dependent resource, which is storage. But if you want to connect your Azure SQL database, you can do that. Can you see? You just need to specify this information. Can you see? Now, the point is, generally what will happen, assume this to be the place where I'll get the data. So what basically happens, the data might be coming from a Twitter account. Okay. It might be getting cleaned. Okay. And then getting stored here in this place. Can you see what I'm saying? It will get stored here. So the data might be coming from a live database also. Okay. So right now we are keeping the static data, but this might be pointing, like actually it might be pointing towards your data lake, wherein you have your live data, which has been processed, cleaned, and then kept here. You cannot clean anything here. You need to run a data pipeline. Okay. Fine. Once you run the data pipeline, then what Azure says is once you run the data pipeline, you can get the data from multiple sources. Okay. Okay. You can get the data from this many sources. But if you want to connect via SDK, you can actually add into that. And then you can run a machine learning model. You will see the results here. You will see the results here in the experiment job only. but you need to build a, what you can say, experiment, and then you will be able to see the job here. Same job you can see here, and if I show, so you can create a database. All right, if I go down here, you can see that you can connect to different storages. Azure File Store, Data Lake Store. One lake is also there wherein you can connect. All right. Can you see? This will be the URL, and this is called as ABFS is Azure Blob File System. Something I do not remember. ABFS is one of the way. And here you can see how can you connect. All right. If you want, I'll share this link. So that doesn't mean when you have Fabric, actually we mean to say that you can connect it from any of the data sources. Now, if I go to this model plus child, here you can see I have got this 3. If you see accuracy of the first one is the highest, second one is almost same, and the third one is this. Okay, so if I see this is max app scalar logistic regression, then I've got voting ensemble, and then I have got max app scalar again a logistic regression. So if I click on this, here you can see one of the parameter is accuracy, but that doesn't mean I cannot go with other parameter. If I like this parameter, I can deploy any model. It's not like, can you see a deploy option? So rather than deploying, I can deploy a model directly. I'll come here. Okay, I have got this 3 things created. I can select any, maybe I like this. I'll click on this. I went to all metrics and I saw, hey, this is far better as compared to the first one. According to me, I can deploy that just by a click. I can click, and now I can deploy it as a real-time endpoint, as a batch endpoint, or I can deploy the model as a web service. Now, what is this batch is for a batch of data. Okay, this batch is for batch of data. Okay, suppose there are 100 inputs that are coming in batch and you want to get the output for the batch data, you can go for batch endpoint. Okay, if you want to deploy it real time, you can deploy real time, or you can click on web service. If I click on web service, this, when we say web service, Azure will take care of your, like here you can see when we say web service, actually you need to define the compute. Okay, so where do you want to deploy? Since this is real time, see both are real time. I'll put it this way. Web service is also real time. Real time endpoint is also real time. When you say real time endpoint, here you do not do anything. Who does the thing for you for deployment? Azure takes care of everything for you. You do not do anything apart from just clicking on deploy. Again, I'll repeat. You do not create any compute here. Azure gives you a compute, a virtual machine. It gives you an endpoint, okay, to this virtual machine, and then you can, if you want to infer the data from the people, you can click on this. If you want to what you can say, package the model. When we say package the model, if you remember container registry, so container registry takes the model as a package. So if you want to enable package, you can do that. If you want to infer the data that will be submitted by the user, you can click on this. This is the name of my deployment. This is the name of my deployment. If I want to change, I can change. Okay, I can give any name, whatever I want to give the name to this. That's absolutely fine. Okay, and here you can see I am not creating any compute. Compute is being given to me directly by Azure as an endpoint. Okay, so I'll directly get an endpoint. Compute will be taken care by Azure. If I click on this, the third one, which is as a web service, here I need to define my compute, AKS compute. AKS is Kubernetes. Okay, so maybe I'll just say deploy model on my own. Okay, now if I do this, here, if you see, I need a AKS compute. So for AKS compute, I need to come here and I need to define a Kubernetes service. I need to define this. Okay, if I want to deploy it on Kubernetes, fine. If I want to deploy, there is another option, what Azure gives directly, which is container instance. What is container instance? It is generally used for testing purpose. This is also a type of compute which is used for real time. So if I search for container instance, you can see there is container instance. So what Azure says, if you already have a Kubernetes spun up, use it. If you do not have, you can actually use container instance. Okay, and you can enable authentication. That means with keys and endpoint people can consume, And now if I click on deploy, understand what will happen. It will actually spun up. I know what is the memory. It will give you around 8 gigs of RAM directly, wherein your model will be deployed. Now, the moment I click on this, you will see that there is a endpoint created here. Can you see? This is the name I gave. So I went to the endpoint option, and here you can see I have deployed a model. I will again start. I created an experiment. I saw the experiment and the jobs that ran in that experiment. This is the job name. Okay, in this job, if you see, in this job, if I click on this job, this is my job. If I go here, you can see I have got the experiments. I can see the best experiment. I can select any. The moment I select, I have an option to deploy. I can deploy it as a web service or an endpoint. Right now, I've deployed it as a web service. For the web service, you need to have your AKS compute spun up, or Azure will give you a compute which is container instance. Okay, you can do that. Another way, I want you to look into the status, deploy status, which is the model. This is the model. I'll just show you. I'll come here, maybe come here. Let me select the first one, and I want you to please pay attention. Can you see there are two things which are saying no registration? Guys, can you see? I hope you can see. So actually there is a model. If I click on this download option, I'll just download this right now in front of you. This is the overall package that you need to have. So I can give it to anyone to deploy. This is the environment. This is the model file, and this is the scoring script. Scoring script means you pass the input, I'll give you the output. This is called a scoring script, automatically created. Okay. Now the point is, I want to deploy this. So before you deploy, always remember you need to register the model. The model is still there in the experiment console. It is not there in your studio. So if you want to deploy the model on a container or on the Kubernetes, then you need to register the model. Now what happened last time? If I again go back to my job, if I select here, if I go to my experiment, and if I go to my child job, I selected this. So what basically happens, the moment you click on this option at the bottom, the moment you click on deploy, it automatically registers the model and then deploys the model. Without registration, you can't deploy the model. I'll show you in a different way. I'll go to my run. I'll go to my model. Let me click on this first one. I want to deploy it as a real-time endpoint. Let me click on this real-time endpoint. Okay, maybe I'm interested to use Azure's real-time system. Now understand I'm using 3 instance count. This is all fine for me. I'll just keep the thing simple. Maybe I want to package the model. That's fine. I want to get inference. That's fine. Just look into this. This is the reason why I'm showing. So registration, no deployment. The moment I click on this, just see the things changing here. Keep a note of this. And see the name, okay? It is giving me 8 gigs to core. I told you similar you will get from the container instance also while you deploy as a web service endpoint. Just give it some time, and here you see. Can you see? I hope you all can see. Now, where is this? If I go to model, you will see 2 models here. Can you see 2 models? So this is right now created, and this is another one. So if you click on this, you can see this is the model that I just created, right? If I go back, so how did it got registered? This is important for you to. Okay, so I've just registered the model. Okay, now if you want to download, you can download. Again, you can deploy any model as an endpoint. Okay, that's absolutely fine. So I've registered the model. If you want to register a model, you can register from here also. Suppose the model is there in the local file, or it is coming from a job output. Right now, let me click on job output. Where is my job? This is my job. Let me select this. Next. What is the model type? I'll say the model is trained actually on MLflow. Which is the model, you can select a model. Okay, so if you have a model, you can directly select it from here. Okay, from the job. I'll just select unspecified type, And if you have a model, you can directly select it from here. If I go back again, let me just change this. Sorry. So you can register any model from anywhere. Maybe I want to register a model from local file. I'll click on this. I need to specify a type. I can select ML flow maybe. Because it is trained using ML flow, I'll click on browse folder. If you remember, I've just deployed a model. So I need to have it is zipped right now, right? So I'll come here. Let me unzip this model. Now what I want to do, I'll just cancel. I'll just select browse. I can browse. So suppose you have already trained the model. You can directly deploy the model now. I'll just select and I'll say upload. Now, moment I say I can upload this model. Now it is saying folder must contain ML model file. So I'll just say unspecified type. Okay, I'll click on next. And now I can give a name. Okay, suppose this is the version that I want to get. I'll click on next and now I can register a model. So now what I'm trying to help you understand, once you register a model, then you can deploy the model. Right now, what we did, we ran the model also on Azure, and then we got the job, and then we submitted the model and then created an endpoint. Okay, so this is the model. Now, if you want to deploy this model, you can, again, this is the new model, right? Suppose you want to deploy, you can deploy it again as an endpoint. Absolutely fine. Okay, helping you understand the overall architecture. Now, if I go to the endpoint, here you can see there are two endpoints. Okay, so I can click on this. Okay, so right now it is still transitioning. So there are different states of this. There is some issue with respect to documentation of this. So basically the state will either be completed or transitioning or failed. Okay, so you can see different states. It's not showing directly, but just to show, I told you there are different states: transitioning, completed, okay, and then there is also something failed. Okay, once it is done, then you will get an endpoint. You will see an endpoint, something popping up here. Right now, if you go to the logs, you can see the live logs. Let it just open. Sorry, let it just open. Now, similarly, I can go to this also. I told you this is being taken care by whom? This is being taken care by Azure itself. So they will automatically allocate. And the first one, I will be able to, this is deployed as a web service. That if it is a web service, I'll directly be able to run it from here. Okay, and this is deployed as a endpoint. Now I want to show you something. If I come up here, the reason is pretty simple. I'll go to resource. This is the resource that I've created. And here you can see whole lot of resource getting popped up. Now, what are these resources? I'll just explain you. If you see container registry, so you have deployed a model and you told you want to package the model as a container. So if I open this in a new tab, understand the overall architecture, guys. This is not required because DP100 will help you understand this in more detail. But since you're doing a project, it's important that you see what is happening at the back end. So what is container registry? Here you can see that we are deploying it as a container. I can go to repository somewhere here under the services. I can go to repository. Okay, within some time you will be able to see that we will have a repository popping up here. What is this repository? This is my package model that you'll be able to see directly here. Okay, just give it some time. It will automatically show up here. Okay, so this is my container registry. If I go back to my resource group and select my resource, there is another thing that you can see, which is this is my machine learning endpoint handled by Azure. Azure is handling the traffic onto this. It is taking 3 instances and this is being handled by Azure. This is my endpoint. Okay, so I have my machine learning endpoint. being created. And you will see two machine learning endpoint. One being created by Azure, another, if you remember, I created. So I can see both the endpoints here. Okay, so I can come here and you will basically be able to see a scoring URI. So any developer or a Swagger thing also you can see. So basically what you can do, you have a Swagger URI. That means you can actually directly go ahead and use this in the endpoint and check what are the APIs available for us to go ahead and consume this. Okay, similarly, I told you this is also one of the things. So if you remember, one I deployed as a web service. So this also we can see, this is deployed as a web service and this is deployed directly as an endpoint. So this is my endpoint. Okay. And it will take a little bit of time because here, if you go, it is still taking some time to show up. Some of the time you can see failed status because allocation of resource in a free account can be a problem. If you have a paid subscription, then this will be far better for you to see. Okay, so what do you have in the lab? I'll just show you. Once you will deploy, 1 second. Once you will deploy, the same thing you will be doing. Everything remains the same. You will create everything what is being mentioned here. Okay. The final thing will be, you will be creating data sets, uploading file. You can see diabetes file, then select, and then you will be doing all this aspect. The main point that I want to highlight is this. If you see, this is what I was saying. So you can deploy this by as an endpoint, real-time endpoint. I showed you two aspects, real-time and directly as a web service. The difference, I'll show it to you directly. That's not a problem. Once you deploy, you will be getting a URI and then you can directly create a notebook. And this is the script. You can use the script to consume the model. This is the script you can use to consume the model. Okay, fine. So this is the script that you need to use to consume the model. The instructions are there. Let me just show up here 1 second. If you see, I told you sometimes it is showing failed. I told you sometimes it can fail. It's not the problem of the deployment. It's the problem of the resource allocation. We are waiting for it to get deployed at least. So I knew that it may fail. I was aware that because I have tried it earlier also. Sometimes it may fail. You can see the operation state. It will automatically stop in some time. The state of failure is not because of any issue. The issue was because of the subscription. When we try to take more than the required compute, because I was running two computes. For one was for container instance, another I asked Azure to give me 3 instances, because of which it can fail sometime. But that's not a problem. Okay, the process is pretty simple. Train the model, see the job, register the model, and after registering the model, create an endpoint. Okay, so you can get an endpoint, and once you have the endpoint, then you can consume the model. Okay, how can you consume? Once you get an endpoint, you will be able to consume it directly via a script because you'll get an endpoint. There is something called as data monitor. Okay, so suppose I want to monitor the data. Okay, and if suppose there is a accuracy is very low, you're getting my point. So what you want to do, you want to change the data set. So if you change the data set, okay, by comparing the what you can say the output, if you're not getting good output, okay, then you can actually monitor the data set and you can change the data set to train the model again. That is possible. You can retrain the model. Configure dataset monitor to detect data drift between the training and the inference data. You're getting the point? Maybe at the time of inference, you're passing some new values, which at the time of training was not available. The features are same, but the values have changed. You're getting the point? Okay. So what you can do, you can create a inference data set monitor, wherein I'll just give you an example. Suppose I'm saying calorie intake initially for a good healthy nutrition food. Okay. For the person to be nutritious was 100. Now the calorie intake, okay, is suppose after some time we saw that people are taking more calorie. And when it is coming to inference, the average calorie was found as 150. And we have told if the data drifts by 33%, what we are saying? If the data drifts by 33%, what do we mean by data drift? The data on which the model was trained as compared to the data that people are now feeding to the model. You're getting? So the model was trained on an average value of 100, but now people are feeding the value, which is huge, because of which the data drift, average data drift for calorie has changed to 33%. So then I would like to retrain the model wherein I'll eliminate these values and try to add this into my data set, model data set, and retrain the model. Okay. Once this is executed, you'll actually get an endpoint, and you will be using that endpoint to score. So this is the script. You just need to use the script. Okay. And once you use you will be able to do this directly in the system itself. Once this is done, you'll be able to see. Okay. Once you run, you will directly be able to see an output. So this is what I'm talking about. Just need to pass that script and get an output. You will be able to get an output. See, the point is this may not look that fancy because this is the work of the front end now. After the model is success, you can give the endpoint and the infra team can deploy it onto an infrastructure. That should not be a problem. All right. I'm waiting for it to get deployed, but that's all about the content. So the process is simple. If I ask you what is automated machine learning, train multiple models using multiple algorithms and find the best model on the primary metric that you have set. But that doesn't mean you cannot deploy any other model. I told you can deploy all the models if you want. You can deploy it as a real-time endpoint or as a batch endpoint. That is also possible. Once you deploy, you will be getting an endpoint and there will be a script, automatically given script will be there. It does take a lot of time to deploy. Okay, it is still deploying. So once it is deployed, you'll get see, I'll just show you. Once you deploy, you will be able to get an endpoint. Right now, the endpoint is there, but still it is getting deployed. So you can use this endpoint and then you can, what you can say, you can directly get a response on top of it.
So today we covered how to predict diabetes using Azure Machine Learning. And we encourage you to try this project yourself and share your experience in the comments section below. And while doing the project, if you encounter any difficulties or have any questions, please let us know. We are here to help you. Remember, if you want to dive deeper and fast track your learning in machine learning and Azure, don't forget to register for the free AI/ML masterclass that I had mentioned earlier. It's a perfect chance to learn directly from experts and expand your knowledge in AI/ML, all while enhancing your career prospects. So the link is there in the description as well as in the pinned comments. And if you found this video helpful and want more informative content like this, be sure to subscribe to our channel. We have plenty more insightful videos coming up. So thanks for watching and definitely make sure that you watch this video next.